This video is going to illustrate an example of how a word problem can lead to a linear programming problem we can solve using the graphical method. So in this example, we imagine a mining company that can mine and transport nickel and iron. Now, nickel and iron weigh different amounts and are worth different amounts. And so it turns out that the nickel that this company mines can be sold for $4,000 per ton, but it takes 200 labor hours to mine each ton. So by labor hour, for example, if 2 people each work an 8-hour day, we would call that 16 labor hours. Iron takes only 80 labor hours to mine 1 ton, but it only sells for $1,000 per ton, which is, it takes less effort, but it also sells for less money. Now, the mining company has resources it can use. It has some miners who can each work 40 hours per week. And it also is limited in how much it can transport. It can only transport up to 30 tons of metal per week. So in a given week, we would want to know how much of each metal this company should mine and transport if it wants to maximize its revenue. Should it mine only iron or only nickel or some combination of the two? So the first thing we want to do is recognize that the unknowns in this question are how many tons of iron to mine and how many tons of nickel to mine. So those unknowns are going to be our variables. We'll let x be the number of tons of nickel and y will be the number of tons of iron. And the quantity that we're trying to optimize here is the revenue, how much money we collect. Well, you get $4,000 for each ton of nickel. If x is tons of nickel, 4,000x tells you how much money you collect for mining nickel. 4,000 per ton times x tons. And for iron, 1,000y tells us how much money the company collects just for the iron it mines and sells. So that's $1,000 per ton plus times y tons. Now, the company is limited in how much it can transport. It can only transport 30 tons of metal total per week. So if you add together the amount of the number of tons of nickel and the number of tons of iron, that cannot exceed 30 tons. It's at most 30. It's less than or equal to 30 total. Nickel takes 200 labor hours to mine each ton, and iron takes 80 labor hours to mine each ton. And the company has 100 miners who each work 40 hours per week. Well, 100 miners each working 40 hours per week is 4,000 labor hours available in a given week. And so the total labor hours spent mining cannot exceed 4,000. In this case, we're looking at 200 hours for each ton of nickel times x tons of nickel, and 80 hours for each ton of iron times y tons of iron. And if you add up that total amount of labor, it cannot exceed 4,000 labor hours. So these two inequalities together are the constraints we need to satisfy. Again, we're going to try to maximize this function, which represents our revenue, subject to the constraints we just obtained from thinking about the description of the word problem. And notice that we have these two extra constraints here that are just for realism, because you cannot mine a negative number of tons of either metal. So the number of tons you mine has to be greater than or equal to 0 for both x and y. Now we have the makings of a linear programming problem, an objective function to maximize and a feasible region described by a system of inequalities. So we solve this the same way we solve linear programming problems. We start by finding our feasible region. We can graph the solution set for the feasible region. We can identify all the corners of the feasible region. We can plug each corner into the objective function. And we ask which output is greatest. That's our maximum. Which output is least? That's our minimum. In this application problem, what we're interested in is finding the maximum revenue. So we're going to be looking for the largest output we can, which is this output, 80,000. So we get a maximum value of 80,000 if we plug in the appropriate corner. So that corner was when we plugged in 20 for x and 0 for y, right here. Which means maximum value of 80,000 when x is 20 and y is 0. In terms of the application, we'll get a revenue of $80,000 if we mine 20 tons of nickel, because x is 20 and x is tons of nickel, and 0 tons of iron, because y is 0 and y is tons of iron. So most of the work in this type of question comes in two parts: figuring out how to change the word problem into a linear programming problem by writing down the correct objective function and the inequalities that are described by the constraints in the word problem. And then once you have that, solving the corresponding linear programming problem just like we did in previous videos.